Started. I'm Jennifer Kretschmer, your CRAN chairperson. For those of you who don't know me, we have a great webinar today. It's called Greywater and Rainwater Made Easy. Our speaker today is John Russell, and I'm going to do a little biography so you know a little bit about John Russell. He received a BS in ecology from UC Davis. John is founder and CEO of Water Sprout, a design build firm specializing in non-potable water systems such as greywater and rainwater systems. John has worked on a variety of projects with diverse clients, ranging from the National Park Service to Virgin Hotels and for residential homeowners. As a recognized leader in the industry, John has presented at numerous conferences and trade shows such as Water Conservation Showcase and the California Landscape Industry Show. John continues to implement solutions to create a water resilient building infrastructure for future generations. John, welcome today, and go ahead and start sharing your screen.
Great. Well, thanks for having me, Jennifer. I really appreciate the opportunity to come talk to you all about greywater and rainwater systems. I have basically a PowerPoint presentation I'm going to be giving you guys today. And then I think with the I think we have maybe around 20, 25 people watching the presentation. So I think it's a small enough group to where if you guys want to unmute yourself and just ask questions as we're going through the presentation, that might be an easy way. We're also sort of break the presentation in 3 sections. So anytime when we come to an end of a section, I'll just sort of pause and ask for any questions before we move on to the next section. So with that, I'll share my screen and we can get started on the presentation. Great, so like Jennifer was saying, hold on a sec, let me make sure. There we go. So yeah, our company is Water Sprout. We're a design build company specializing in greywater and rainwater catchment systems. Oftentimes we also collect groundwater that can be reused for non-potable uses like irrigation systems, toilet flushing. We also do water use monitoring systems. And then we also do exterior fire sprinklers just in response to all the wildfires now sort of threatening homes all around the Bay Area. We've been doing this for a while here in the Bay Area. We have over 200 systems installed, both at the residential and multifamily commercial level. So we're going to do 3 sections to this presentation. The first is just sort of a general overview of greywater and rainwater systems. The second section, we're going to touch on the question of ROI, return on investment, which is a common question we get. And we'll cover some other important considerations, other questions to be asking as well. And then the third section, we'll look at how do we implement these systems? What are some barriers? What are some opportunities for implementation? And then future requirements that are sort of coming down the line from counties, cities, and the state. So the greywater systems are addressed in the California Building Code, Chapter 16, 15 and 16, and they sort of break it down into 2 different areas: untreated greywater systems, which is greywater that's just being used for subsurface irrigation, and then treated greywater systems, which is being treated and reused for non-potable uses inside of buildings like toilet flushing, trap priming, and things like that. So when we're talking about untreated systems, that's typically what we see at single-family residences and even multifamily residential projects, where we're just using it for irrigation water. We just need to filter it to 100 micron size to prevent the drip emitters from clogging. If we're doing on a multifamily project and it's untreated, we'll do a little more treatment on it. We'll aerate it, we'll allow sedimentation and light biological filtration to take place just to create a better water quality for multifamily homes. But single family homes, usually that's just very minimal treatment, just filtration to 100 micron size. And then for treated systems where we're treating the greywater for like toilet flushing, it has to be an NSF approved system, and it treats the water to a much higher quality, almost like if you pick up a glass of the treated water, it'll look like normal potable water. There's not going to be any sort of color or tint to it. But usually that employs like membrane bioreactors and ultrafiltration to get it to that high of a quality. So typical Greywater breakdown is a typical Greywater breakdown. You can see the showers and clothes washers are the two greatest producers of Greywater in a typical building, with like faucets being a secondary one. Kitchen sink or food prep areas is considered black water and is part of the, is sent to the sanitary sewer. But the majority of the water being produced by a building is Greywater and can be reused. So, so if we take like a typical multifamily project, we have this sort of generic 50-unit residential housing project here where we might have 1.5 occupants per unit. Each occupant in this type of situation might produce around 25 gallons per day of Greywater. And that's usually a little bit less than single family residences, which tend to use more water than occupants in multifamily houses. So if we have if they're all using about 25 gallons per day, then the whole building will generate about 1,800 gallons of Greywater per day, or 684,000 gallons of Greywater per year, which is quite a bit of Greywater. And if we're just using it for landscape irrigation, that's probably going to be way larger than the amount of irrigation demand for the landscape, just because these buildings typically don't have a huge amount of area to irrigate. So when it comes to multifamily projects, a lot of times we'll just collect from the laundry rooms, the common laundry rooms if they exist inside the buildings, which can keep plumbing costs a lot cheaper and is more affordable than collecting from each individual unit. So in this example 50-unit building, if we're just to collect from the laundry water, then that's still 506 gallons per day or 184 gallons per year, which is still usually about, can supply about 100% of the irrigation demand for a typical site. If it's not like a 5 or 6, story high-rise multifamily building that's sort of spread out with larger landscape, then it's going to require more irrigation water, and we might not be able to supply 100% with just the laundry. But typically, like if it's a multi-story building, then with sort of minimal landscaping, then we can supply 100% of the irrigation with it. So for a single family residence, one person produces anywhere from about 20 gallons to 40 gallons of Greywater per day, depending on their, if they're taking long baths or long showers. And so a typical family of 4 produces anywhere from 30 to 40,000 gallons of water per year that can be used for irrigation. So the great thing about Greywater is it's produced all throughout the summer when irrigation water is peaking. So we have this graph here showing the irrigation demand generally is going to be peaking in June, July, August, the hottest months of the year. And then our Greywater supply is just sort of consistent throughout the year. So because of that, Greywater systems can use much smaller storage tanks because the Greywater is just being stored for maybe a day or two before it's being used by the irrigation system. So a common question we always get is, well, okay, we can collect Greywater, but what about the products we use in the Greywater system? What's going down the drain? What's appropriate to use? So in general, all your typical hand soaps, conditioners, shampoos, that's all fine to use with the Greywater system. The one thing you need to be concerned about is the laundry detergent that used. Many laundry detergents, especially the solid detergents, have a high salt content, and we don't want to be adding salt to the landscape. But most liquid detergents, and then there's a few, not a few, but there's about 7 or 8 that we recommend that have a very, very low salt content that are appropriate for Greywater systems. Antibacterial soaps, we don't see those too much anymore. They're sort of being phased out, but we want to avoid that because it can kill beneficial soil bacteria. And then we want to use chlorine bleach alternatives like hydrogen peroxide. Again, if these products, even if they use like a little bit of chlorine bleach occasionally, that's not going to really do too much damage. A sort of sustained, consistent use of these products might cause some damage to the soils and the plants. But you know, if one of these products are just used very occasionally, once in a while, then it's not going to like kill everything in the landscape. So here's just sort of a typical diagram of a Greywater system. So we're collecting from our showers, our laundry, our sinks, and then our toilet is separate. We don't collect from the toilet or the kitchen sink or food prep sinks. And all the toilet and kitchen sink would drain through a separate drain line to the sewer. But all the gray water first goes to a diverter valve, which allows us to send the gray water into a tank, a storage tank, or to divert the gray water back to the sewer. So during times of maintenance, or maybe in the wintertime when we're not necessarily irrigating the landscape, then all the gray water can be diverted to the sewer at those times. Typically, we're storing the gray water in a tank. For a residential site, that might be like a 250 gallon. For a single family home, that's 250 gallon tank is typical, what we use. There's a pump inside the tank that then pumps the gray water to a filtration system, which further cleans the gray water so we're not clogging our drip emitters. And then from that sort of filtration system, it goes out to the irrigation valves in the landscape. Makeup water is usually needs to be applied to the system. If there's no gray water in the tank, then our makeup water supply is added to the system to ensure there's a constant supply of water there available for the irrigation system. So here's a picture of a typical single family home tank installed underground in the landscape. And that's our typical location for the gray water tank to go, is out buried in the ground in the landscape. And that's probably about 80% of our projects will have a underground tank in the landscape. So, and there's a person's feet back here. You can sort of get a little perspective on how large a 250 gallon tank is, but it's about four foot diameter, 4 feet tall. And all the gray water gravity drains from the house into the tank. Sometimes if the house has like a basement mechanical room, we might do an above ground tank in the basement mechanical room. So here's a picture of what that would look like with all the associated plumbing. Typically we try to do it out in the landscape if possible, but for some reason it's, because of where the sewer lateral is running, or if there's just not a great place to put the tank, then this is an option. So for multifamily house systems, we typically employ a 2-tank system where we're able to treat the gray water to a higher water quality for the project. And so the tank sizing depends on how many gallons per day the system is producing. So the smallest system that we see at a multifamily housing project would be like a 325 gallon tank, and there would be 2 of them. And then depending on how much gray water we're trying to treat and supply, we might go up to 1,000 gallon tanks or larger size. So in this picture here, those are 700 gallon tanks, and you can sort of see the person standing there. That gives you a little perspective on how large those tanks. Another option for tanks at the multifamily level is a lot of times they'll have like underground parking garages under the building. And so in that application, we could do like 2 concrete tanks underground in the parking garage, or sometimes there might be room for like above ground tanks in a separate room somewhere. So our system has what we call a filtration manifold, and this type of setup where you're pumping gray water through a set of filters before it goes to the irrigation is typical of any gray water system. Our system, we just call it the filtration manifold. So filtering gray water is among the hardest tasks of any gray water system. There's a lot of debris in the gray water. There's lint from clothing, there's dirt, there's whatever washes off our bodies, skin cells, everything that all goes into the tank. and gets pumped out and needs to be filtered out of the water somehow before it goes to the irrigation system. So definitely maintenance of filters should always be a consideration when choosing a gray water system. We really recommend that a once per year maintenance minimum. You know, if you ever contact a gray water vendor and they say, oh, you have to be cleaning filters like once every month or something like that, then that system is going to fail, because no user is going to get out there and clean a filter once a year. So really we recommend, once per year maintenance maximum on the gray water system. Oh, in our systems, they employ auto back flushing filters. So yeah, whenever you're thinking about a gray water system, our system has an auto back flushing filter that basically cleans itself periodically so that no user is required to go open up the filter and manually clean it. So systems with sort of auto back flushing features are really desirable for gray water systems to reduce maintenance. So here's some general pricing for our systems. So single family home, our designs typically are a little under $5,000 for a design. And usually we draw up plans and submit them for permit along with the main submittal package, the building permit submittal going into the city. Sometimes we can do it separately as a separate permit if the building permit has already been obtained. And then installation varies between about $25,000 to $27,000 for the installation of the system. That doesn't include the indoor dual plumbing that needs to occur, which is separating the gray water fixtures and the black water fixtures in the house. That's usually done by the project plumber. So that's going to be an additional cost onto what cost you're seeing here. And then for a multifamily project, the prices go up a little bit, usually around $10,000 for design. And then a typical 500 gallon per day system that's able to supply 500 gallons per day to the irrigation system is going to be about $60,000 to install, not including the indoor plumbing. So, now I'm going to switch gears to rainwater systems. Does anybody have any questions about gray water systems before we move on to rainwater? You can go ahead and just unmute yourself and ask a question if you want.
Hello. Oops. Go ahead, Judith.
Thank you. I was looking at these tanks, and by the way, John, very nice presentation.
Oh, thanks.
You and I worked together in a project in Sunnyvale. Greywater and rainwater, and it turned out to be $60,000, and the holes were humongous.
Yes.
So my question was, how much of this cost goes into digging and disposal of dirt?
Yeah, so that's rainwater systems, which generally have much larger tanks than gray water systems. So yeah, a lot of the cost can be associated with large storage tanks where we're talking about maybe a 5,000 or 10,000 gallon tank. So in the second section, when I start talking about rainwater, I'll start sort of addressing those costs and what's involved with excavation for rainwater tanks.
Thank you.
Looks like Fernando.
Yeah, I actually had a question and I thought of another one, but so the first question is I wasn't aware of the filtration. What is, can you give an example or two of what actually those filters are purposed to be filtering out?
Yeah.
Like what types of, is it salt? Is it, acidity? Like what types of things it's the purpose of them to be filtering?
Yeah. So the purpose of the filters is just a mechanical filtration so that we're not clogging the drip emitters in the irrigation system. So any drip tubing and drip emitters, you're going to see a spec where they require 100 micron filtration upstream of the drip emitter so that you don't clog it. Oh. So at the single family level, that's all our system. It doesn't do biological filtration. We're not removing salts or nutrients from the water. We're just mechanically filtering it so those drip emitters doesn't clog. So basically anything that is going down the sink is going straight into the soil. When it comes to like shampoos and conditioners and stuff, that's actually mild that has a lot of nutrients in it for plants and soil bacteria to break down and use. So gray water is actually sort of like a mild fertilizer because of all that organic material that is in the gray water. But yeah, like anytime there's bad stuff going down to the sink, like, salts or, some sort of caustic cleaners, that will end up into the soil.
I see. So it's just like particulate matter, I guess is what it's for. Maybe I don't know
Yeah,
if you
it's
get hair in
lint.
there.
Yeah,
Yeah.
it's a lot of laundry lint that we're going to be capturing. It's dirt. When people take showers, dirt comes off their body.
Yep.
Skin cells, whatever else you can think of going down those drains. That's what
All
we're
the fun
filtering out.
stuff. Yeah, that's why I don't want to open it up because. So is there a maintenance? I mean, nothing is maintenance free, but is there a cost? I mean, it costs 25, maybe 30 all in. Is there a maintenance cost yearly that is
Yeah.
noticeable, or is this just like any other thing you buy? It's not really a big maintenance burden on the
Yeah,
homeowner.
so we offer maintenance contracts to our clients to come once a year to perform maintenance on our gray water systems. And depending on where they are in the Bay Area and their system, it can range from anywhere from about $250 to $400 for us to come do it.
Yeah.
Now, we do produce a manual that lists all the maintenance. And so, for instance, if a client has maintenance people involved in other activities at the house, they can certainly add that to their task. It's not like rocket science maintenance when it comes to these systems.
That's a good option to have. And then one just last quick question is, how do you typically get involved with homeowners? Are you direct to homeowners? Do you work primarily through architects and other people in the trades? Or like how does somebody know to contact you and find you?
Yeah, we work directly with clients. Sometimes, people contact us from all different, clients directly contact us, architects, landscape architects, engineers will contact us and say, hey, we have a project for a client's interested in a gray water system. Can you get us a proposal? So we have all different avenues of ways we make connections for projects.
Okay, great. Thank you for that, for the answers.
Mm-hmm. Any other questions before I move on about gray water? Okay. Great. So moving on to rainwater. So rainwater can also be used for landscape irrigation, both subsurface and spray irrigation. We can also send rainwater indoors for non-potable uses like toilets and laundry, trap priming, and other non-potable uses inside of building. And then there's even a Appendix K of the California Plumbing Code, which allows for indoor potable use of rainwater systems. We don't see a lot of those, and that's a really rare thing, just because most people have access to, municipal drinking water, and so, they're not so inclined to install an expensive rainwater system to treat it to potable standards, but there is that ability to do that. So rainwater is addressed in Chapter 16 of the California Plumbing Code. And like I said, there is that Appendix K that allows for potable water systems, which is pretty amazing that that's actually in the plumbing codes. We've only done, I think, two potable water systems. One was in San Francisco, which was the first of its kind. It had never been done before. But yeah, like I said, it's pretty rare and it's sort of expensive for all the treatment equipment to be able to treat it to potable standards. So here's a chart that shows sort of the supply, rainwater supply that you might expect in California. So obviously all the rainwater comes in the wintertime when it's raining, and then we have this sort of extended dry period in the summertime when it's not really raining. And so if we sort of overlay a irrigation demand over it again, because it's all coming in the wintertime, and we sort of need to capture that rainwater and store it for use in the spring and the summer, then we typically need larger storage tanks to be able to store that rainwater. So on this chart, we have a hypothetical 5,000 gallon rainwater tank that we've installed. And if we're expecting about 40,000 gallons of rainwater during the year, and our irrigation demand is about 64,000 gallons of irrigation per year, which might be a typical amount for like a ½ acre or a 3/4 acre project here in the Bay Area. And we can expect that 5,000 gallon tank to collect and use about 11,000 gallons of rainwater before it goes empty. And you can see it, sort of it's full all the way up until May, and then it quickly drops off. And by June or July, the tank is empty all the way through the rest of the year. So that's, typically when we talk to clients too, we usually recommend a Greywater system first because of the constant supply of Greywater through the year. We can use a much smaller storage tank, only a 250-gallon tank size for typical single-family residence. So because of that, the cost of the system is usually much less for the amount of water saved for a Greywater system, because we don't need these large storage tanks. So because we can use rainwater for indoors pretty easily with just some extra filtration equipment, here we have a graph where we actually are now using rainwater for irrigation, which is the 64,000, and then now we're using it for toilets and laundry inside the building as well. So that same 5,000-gallon tank can actually now save about 28,000 gallons, whereas if before we were only saving about 11,000 gallons of just using it for irrigation. So indoor usage of Greywater for toilet flushing and laundry is actually a really good usage because we can use it all in the winter time. People are flushing their toilets, doing their laundry all throughout the winter when it's actually raining. So the tank is filling and emptying through the winter, which is sort of the ideal scenario for a rainwater system. So here's a diagram of a typical rainwater system. We're capturing rainwater off the roof, which is usually the cleanest water source coming off the roof. Oftentimes we will capture from surface drainage, like off patios and hardscape areas around the house. That water tends to be a little bit dirtier because there's more likelihood of dirt and debris flowing into surface drainage. And so the water is dirtier, but roof water tends to be the cleanest water. So the Greywater or the rainwater goes through a pre-filter, which filters out the majority of debris that is in the rainwater before it goes into the rainwater storage tank. And then there's usually like a bypass or an overflow on the pre-filter. If it gets clogged or something like that, the water will continue to flow through the system and won't just flow out of the top of the pre-filter. We're storing the rainwater in a storage tank. And then similar to the Greywater system, we're then pumping the Greywater to a filtration system that filters the rainwater to 100 micron size before it goes to the irrigation system. And then we might also be supplying the rainwater to the toilets and laundry inside of the building. Similar to the Greywater system, the rainwater system needs a makeup water supply that in case the rainwater tank goes empty, then we have a constant water supply there for the irrigation system or the indoors uses. So rainwater, there's a lot of options for rainwater pre-filters. The kinds we typically use are underground pre-filters. Most of the tanks we install are also underground tanks. And so the pre-filter is just sort of upstream of the tank, filters all the rainwater before it goes into the underground tank. And a lot of the underground filters have a setup where there's the inlet coming into the pre-filter. There's some sort of basket, like a stainless steel basket mesh that filters the rainwater. And then the filtered rainwater flows out to the tank. If the screen of the filter ever gets clogged, then it usually has a bypass so that water can continue to flow out the bypass and doesn't just overflow into the yard. There are other options for pre-filters other than underground ones. There's downspout filters that go directly on the downspouts that can be installed, as well as gutter screening. You can have just screens straight on the gutters that filter the rainwater as it goes into the gutters. So those are some different options for pre-filtering. But pre-filtering is pretty essential to the system. Anytime anybody complains about, rainwater in a tank that is stinking or smelling, that's because they are not employing a pre-filter that's removing the organic material before the water goes in the tank. If you have good pre-filtration, then the water can sit in a rainwater tank pretty much indefinitely. It's just sit there forever, and there's not going to be any water quality issues with the rainwater in the tank. So here's some examples of different options for rainwater tanks. Here's a 10,000 gallon below ground fiberglass tank. So in larger tank sizes, fiberglass is a good option to use. It's pretty lightweight, easy to move around a site. Other options are above ground steel tanks. Like on the left, there is a corrugated steel. On the right is sort of like a flat steel tank. And then there's also concrete tanks for underground applications that are sort of modular concrete cast systems that can be sort of assembled on site after you dig the hole. So that's another option for underground storage. And then similar to the Greywater system, there needs to be some sort of final filtration on the rainwater. Because rainwater is an inherently clean source to begin with, as rainwater is falling through the air, there's very little materials or particles in the rainwater. It's only when it hits the roof and starts collecting dust and debris that materials is introduced into the water that needs to be filtered out. But again, if we're just supplying irrigation water, then we want to filter to 100 micron size minimum. And then if we're sending indoors, we want to filter it down to an additional 5 micron and then disinfect the rainwater. Using like a UV light system is typical for disinfection for rainwater systems. More and more counties and municipalities are requiring that if you're going to use rainwater for indoors, that you have to have an NSF 350 treated system, approved system to treat the rainwater before it goes indoors, which means that, again, we have to use like membrane bioreactors and filter it down to like 0.2 microns. So it's sort of a higher level of filtration, which can add, a significant cost to the systems. Looks like David has a question real quick.
Yeah, so the filtration, whether it's 100 or 5, doesn't address dissolved solids and organics. Specifically organics that you get off like dimensional comp roofs or any kind of degrading organic material, not organic, petroleum material they have on an exterior of a building. How do you deal with those?
Yeah. So if the water's just going to the toilets, then that stuff isn't as much concern. But if you're doing obviously a potable water system, then if you're having leaching from your asphalt shingles off your roof going in your potable system, that is a high concern. Sort of in the medium category is laundry. If you're sending rainwater to the laundry, then obviously clients are going to be maybe somewhat concerned that the petroleum products might be leaching from their roofing and interacting with their clothes that are in the laundry machine. So yeah, there's sort of a host of decisions that need to be made there as far as what the client's comfort level is with rainwater and interacting with their clothes, and what building materials that the rainwater is coming in contact with. Okay. So you sort of have to make those decisions sort of as you go through what we're sending the rainwater to and what the building materials are being used. Obviously, if you have like a steel or even like an NSF approved potable water roof membrane, then that's going to be much less concern about things leaching into the rainwater that could potentially be hazardous to people.
And then a question about a previous file you had where you had the makeup water going into your tank.
Yeah.
So there's, from my experience, there's basically 2 ways that you pass it. There's 2 ways of dealing with kind of the toilet laundry system. One is having the dedicated, one is dual piping it. So you have 2 valves going into like a toilet tank or something like that. The other one is replacing the potable water system from your jurisdiction with the dedicated rainwater manifold system that you would then have to fill up with the potable water system, right? So that's is that what you're referring to in this letter or this figure?
Yeah, the makeup water system is usually like the potable domestic water line coming into a project, although it might, in a rural area, that might be like the well. that provides domestic water to the house might be the makeup water supply. So it depends on the project what the makeup water supply would be coming into the rainwater system.
Okay, so then you're not,
yeah, go ahead.
sorry. So you're not double piping water lines. You're not having to switch
No.
between the normal. Okay.
Yeah, usually we try to have the makeup water supply come into our rainwater manifold, and that's a central location that then feeds all the toilets and laundry and irrigation valves on the project. So we're not running separate plumbing to toilets where you're switching over to the potable water system at the toilets. That's sort of cumbersome. We try to make it just one central location to have the makeup water interact with the system.
And then you're basically having a pump keep that entire system pressurized the whole time?
Yes, correct. Yeah. Usually we add makeup water through an air gap into the systems, and then the rainwater pump or the Greywater pump is responsible for pressurizing the system.
Okay. And then do you have any issues with like pressure assisted toilets with the rainwater system? Yeah,
usually you need to have large pressure tanks on the system that can supply the instantaneous demand required by those pressure assist toilets that you might see in larger, multifamily or commercial projects.
Okay, awesome. Thank you very much. Appreciate it.
Okay. Let's see, we were just finishing up. So rainwater systems, final pricing on the systems. Designs for a single family system is a little over about $5,000 that we charge for design work. Installation, about 23 to 26. If we're just supplying irrigation, if we want to supply rainwater to indoors at the single family level, then it's a bit additional, about $6K in equipment costs and installation costs. And then the big cost with rainwater systems is those storage tanks. So, if you're installing a, 1 to 2,000 gallons of water underground, that might be like a $15,000 cost to install that. If you start installing much larger storage volumes, 5, 10, 30,000 gallons, then the costs start going up. So for instance, we just installed a 30,000 gallon above ground steel tank on a project, and that cost the client about $81,000 for 31,000 gallons of above ground storage. So yeah, so a lot of the cost with rainwater systems is associated with the tanks. And then there's always the decision, if you go underground, there's the excavation costs involved with digging large holes. You have to place the tank, there's backfill material. You usually have to remove the excavation material from the site unless you're doing a lot of grading and fill on the site. So definitely the cost of the tanks and the size of the tanks are a big determining factor when it comes to rainwater system cost. Again, the costs are a little bit more for multifamily systems. Usually the flow rate might be a little bit higher. The pressures might be higher if we're needing to pump the rainwater up to some roof planters or something 5 or 6 stories up. So the system tends to be a little bit more robust, cost a little bit more for multifamily housing. Great, so that's the end of our Greywater rainwater. We're gonna move on next to question of ROI. Are there any questions about rainwater before we move on? Yeah.
Considering that we're in a drought and there's no indication that this may ever end. And, you're getting into the return on investment, but I'm even thinking of just having enough water to use.
Yeah.
It just seems like, those curves that you showed us make much more sense for Greywater than they do for rainwater. It's like the solar power curves, right?
Yeah.
You get solar power in the middle of the day when you don't turn any lights on because it's light out. But then at night when it's dark, you don't have any solar power.
Yeah.
What? I guess you're going to address this, so I'll shut up.
Yeah, well, I'm going to talk about some other important considerations, which is, yes, we are in a major drought right now, and when is that going to end? It's one of the major considerations. So, Okay, if there's no other questions, I'll start in on this next section.
Hey, John,
Yeah.
one question when we're talking about drought. So do you end up with systems which are kind of mix of gray water and rainwater, like both systems, or is it not advisable economically? And,
Yeah.
you know,
Yeah, we do combined systems where we have both a gray water and a rainwater on site. And when that happens, usually we use the gray water first because it's a smaller tank and we want to not start overflowing the tank. So the system we use gray water first. If there's no gray water, then the system switches to using the rainwater. And then if there's no gray water and no rainwater, then we have our makeup supply coming into the system to ensure there's a constant water supply there. But yeah, oftentimes we'll do both a sort of a combined system. The storage, the tanks, like we need to store the gray water and the rainwater in separate tanks, but then basically we can pump to the same manifold, which then sends the gray water and the rainwater out to the end uses.
got it. Thank you.
Mm-hmm. Okay, so we're gonna cover the ROI or return on investment of these systems, and then we'll move into some other important questions that we should be asking at this point in time. So what is the ROI on these systems? So when I'm asked this question, I used to take it pretty seriously. I would break out my calculator and look through water rate tables and click and scan through water bills. But after a while, I started getting a little suspicious of the ROI question, and I began to question if this was such a great decision-making tool. If you take the ROI question as the most important question to answer, like what kind of outcomes do you actually get? So I begin to look more closely at some of the outcomes we get of really good ROIs when you look at other industries. So here's what a good ROI looks like for the lumber industry. Clear cutting of forests to get as much lumber out as cheaply as possible. So this is what happens when ROI is used as the prime decision-making tool in the lumber industry. So in the mining industry, they tend to remove mountaintops and create mining ponds filled with toxic waste that leak into streams and rivers and aquifers. So this is the mining industry's version of ROI. Coca-Cola has a history of installing bottling plants in India that deplete the groundwater in the region and then discharge the waste into local streams and creeks. Their ROI on their product is so good that they have 58 bottling plants in India alone and continue to install bottling plants in poor communities with lax environmental regulations. So I've come to realize the ROI question based on these examples can actually lead to some bad decision-making. And maybe more importantly, the ROI question distracts us from some truly important questions that we should be asking right now. So a really important question that we should be asking ourselves and need to answer is, how do future generations inhabit our cities during a 50-year megadrought? So a study published recently, or about 2 years ago in Science Magazine, showed that the Southwest is currently in a 22-year megadrought. By looking at the tree ring data, scientists were able to look at water conditions spanning back about 1,200 years, which show there's been a handful of extreme megadroughts during that time. So our current megadrought began in the year 2000 and has been most likely made worse by climate change. The second takeaway from that study was that the tree ring data showed us that the last 100 years have been wetter than normal, meaning that we may have a false sense of how much water is actually available for us to use. Another question we should be asking ourselves is, how do we diversify our water supplies to account for a future of less reliable water? As climate change continues, less precipitation will fall as snow in the Sierras, which will result in less water flowing into our reservoirs during the dry summer months when we really need the water. In addition, about 85% of Californians rely upon underground aquifers for some portion of their supply. Much of these aquifers, particularly in the Central Valley, have been overdrafted for decades, which means we're pumping out water faster than it's replaced by precipitation. Essentially, we're just draining our water bank accounts right now, and this situation has been particularly exacerbated during the last 2 decades. Another question we should be asking ourselves right now is how we can reduce the majority of electrical use throughout the state and combat climate change. The single greatest user of electricity in the state is the pumping, transportation, and the treatment of water. The Bay Area, LA, and San Diego all rely upon water transported from hundreds of miles away. And these major water systems are aging and are going to need an enormous amount of money to fix and maintain in the future. So these are some big questions that we're going to need thoughtful answers and solutions to. And as designers, we really need to consider how we're going to create water resilient buildings that are ready for the challenges of the next century. So that's the end of section 2. Thanks for hanging with me with my little activist rant there. So section 3, we're going to talk about how do we implement these systems? What are some barriers to implementation? How do we convince clients that these are systems that need to be installed? And then sort of the future of non-potable water systems, concerning regulations and what might be coming down the pipeline. So one reason a client might elect to install one of these types of systems is because it's being required of them. This particular project in San Francisco is a mixed-use market rate apartment building with about 61 units. We designed and installed a 22,000-gallon rainwater system under the parking lot basement, which collects rainwater and uses it for irrigation. So we do a lot of these types of rainwater harvesting in San Francisco on buildings because of the SFPUC's stormwater management ordinance, which requires that stormwater be managed using one or multiple techniques, such as rainwater harvesting, flow through planters, and green roofs. So in this instance, you know, when the developers are developing these buildings, they have to comply with these rules and regulations. And we are always pushing architects and civil engineers to choose the rainwater option to meet the stormwater standards. Because unlike other options, such as flow through planters and green roofs, those options don't really save water. They're actually water users because you have to irrigate the green roof or flow through planter to keep it green throughout the summer. You know, installing a rainwater harvesting system where you have 22,000 gallons of storage there on site actually saves quite a bit of water and makes that building much more resilient in the future. You know, if water situation gets really, really bad here in California, being able to store 22,000 gallons of water in that building, that's going to be a huge benefit to that building, much more so than a green roof or a flow through planter. So oftentimes there is funding or grants available for these systems, which can help defer the costs of the installation. So we did a project at the Children's Discovery Museum in San Jose where the owners applied for and received a grant that paid for about 80% of the rainwater system cost. The museum was able to develop some signage in their outdoor classroom that teaches kids about the water cycle and how to conserve water. So a lot of schools or educational sites can access grants, and that's a great way to implement these systems and increase the likelihood that these systems are being installed, help defer the costs. Another motivation to install a non-potable water system is that can qualify for LEED points or green rated points. So this particular project we installed in Los Altos Hills, it's a single family residence. They were going for, I believe this was LEED Platinum on this project. And so the Greywater and the Rainwater systems were helpful in achieving that LEED Platinum status. So this can also be a big driver and motivation is trying to get LEED. There's also other things like net zero water goals, sustainable house goals. There's, in addition to LEED, there's all sorts of different rating systems that now that are popping up where water conservation and these non-potable water systems can definitely help. So looking forward in general, more and more cities and municipalities will just be requiring that these systems be installed. We already talked about San Francisco's stormwater requirements. In Marin, for instance, the water utility, MMWD, requires projects that have new or upgraded water meters install a Greywater system. Portola Valley, LA, and a couple of cities in San Diego County require dual plumbing for future Greywater systems. The city of Menlo Park requires that all new buildings above 250,000 square feet supply alternative water to irrigation, toilets, and other non-potable water demands. So we're just going to continue to see cities increase the requirements for these types of systems on projects. And as the mega drought continues, we might see some actual action from the state as well. So, you know, it's in everybody's best interest to sort of get ahead of the curve as these systems become more required and more mandatory. You know, it's good to sort of be on the leading edge rather than just sort of following and be on the back step. Great, so that's the end of our presentation. If anybody has any questions, I would love to answer some more questions.
Thank you, John, so much. Yes, let's open this up to questions now.
I have a little problem with the made easy part. On account of none of that looks easy.
Well, that's why you hire us, because we make it easy.
Yeah, I'm really good at it, but you're not cheap either. I think Palo Alto requires laundry to landscape. No, it's not that they require it, it's they allow it without a permit.
Yes, that's a statewide, that's in the California plumbing code that you can install a laundry to landscape Greywater system, which is just collecting from your laundry machine, no other Greywater sources, and piping that outside to irrigate about 6 to 8 larger shrubs or trees. So you can legally install that without a permit statewide.
Okay, so suppose that say your laundry is in your garage, just common, and your garage is a 20 by 20 concrete slab, which you're going to dig up and pipe underneath. And your landscape is on the other side of your house. How do you get your water to your landscape?
Yeah, that's hard. If the landscape's on the other side of the garage from the washing machine, then it's going to be difficult to get that water over with the laundry landscape system. That's the thing about Greywater systems, though, in general, is that they can be difficult to retrofit into existing homes. Like the majority of our business is at new home construction or major remodel, just because it's so much easier to do the plumbing and install these systems with new construction. You know, retrofitting it can be very difficult and sometimes impossible on projects.
Okay, thank you.
Yeah.
I feel a little better, but not a whole.
So I couldn't help you more, Jude.
I have a question.
Sure.
So our architecture firm already has 2 incorporated Greywater systems and rainwater capture at our offices, but I'm wondering if you have any information on the permitting process for rainwater to potable.
Yeah, so all that is mentioned in Appendix K of the California Plumbing Code that lays down the rules and regulations for potable water systems. So if you just go reference that Appendix K, then you can find out what the requirements are.
Okay, awesome. Thank you. And just piggybacking on Erica's question, we both work at the same architectural firm she mentioned, Archinexus, but I am based out of Salt Lake City. She is based out of Sacramento. I'm a little unaware of the plumbing codes, but the code you're mentioning, is it both for non-residential and low-rise residential, or is it only pertaining to residential?
The Appendix K I'm actually not sure about that. Like I
Okay,
said, we
yeah, no problem.
rarely do potable water, rainwater system. That's just super rare. And we've only
Right.
done 2 of those in the past of our, 15 years of existence. So I don't know the answer to that question if it applies to just residential or other areas.
Okay, and I have a quick last question, and then
Yeah.
I promise this is the last one from me. Um, uh, so I love your slides on ROI.
Mhm.
I feel like just basing all the decisions on a cost only is not gonna be enough for us
Mhm.
right now. Have
Yeah.
you ever been in a situation where though you had to bring up costs because
Yes.
how much ever your design team and you want to promote the right decision, your client is demanding
Yeah.
ROI cost
Yeah.
basis,
I have to tell them something, right? I can't give that spiel to
right?
them when they ask me about ROI. So what I always tell them is that ROI on these systems is very long-term because water is still so cheap. And so you're looking at 20, 30 year, 40, maybe never on some of these larger systems. And so, but how I pitch it to them is that I sort of think of these systems as insurance policies. So on a single family residence, if it's a new home and they just did a large landscaping project and they just purchased $100,000 worth of plants to install in their new landscape. And then let's say 2 years from now, the city tells them they can't irrigate their landscape anymore, which has happened up in Healdsburg last summer. They cut off all irrigation water to the residents and said, you cannot irrigate your landscape because we don't have enough water, right? And so people are just scrambling, trying to figure out what to do to keep their plants irrigated.
That's interesting to know.
So it's sort of an insurance policy, because if you have a Greywater or Rainwater system on the site, you can continue to irrigate those plants, and at least maybe, the systems might not supply 100% of the irrigation demand. Maybe they only supply 40 or 50%, but you can at least keep those plants alive. The $100,000 you just paid in plants, you can keep them alive until maybe next year or the following year, when it maybe rains a little bit more and they can subsist, or the drought restrictions get reduced. So I always say it's almost like an insurance policy that you can ensure your landscape is not going to die from that big investment that you just placed into it.
Mm-hmm. Yeah, thank you.
Are you aware of any Greywater or it's not really Greywater, but any water reuse systems besides the one in the Palo Alto house called Project Green Home that pulls water from the kitchen sinks?
No, I'm not any aware, because kitchen sinks is considered black water. And so that becomes a septic issue and not a Greywater issue. That's just not classified as Greywater. So you're never going to see a Greywater system that's accepting that. There's always pilot projects and things like that, and experimental systems that people are doing. But yeah, we've never done a system where we are collecting from kitchen waste because it's not Greywater.